So this lesson is a new type of Punnett square, and I think out of all the kind of different types of Punnett squares, this is, I think, the trickiest. And hopefully I'm wrong. Hopefully you find this to be very, very easy, but this is usually a little bit tricky. So it's called sex-linked traits, and the reason they're called sex-linked traits is because they have to do with sex chromosomes. So if you look at our little pictures here, on the left side is meant to be a female, the right side is a male. So on normal chromosomes, there's a pair of chromosome 1s. So that means that, let's say there's an eye-color gene here, there's an eye-color gene here. Okay, this is, we'll say, normal Punnett squares. And there's a hair color here and a hair color here. So same thing on males. 1, 1, 2, 2. So like on normal chromosomes, they has 2 alleles for every trait. But the thing is, some genes can be on the sex chromosomes. And that's where males and females are different, because you know that females have 2 X's and males have an X and a Y. So let's just say there's a gene for being colorblind. Females would have 2 genes or 2 alleles for colorblindness because it's on the X chromosome and they have 2 of them. But males would only have 1 gene for colorblindness, and the Y has nothing on there because the Y doesn't have it. So it's possible to have only 1 gene for that. And that's really different because in past Punnett squares, you'd have to have a dominant and a recessive, and then it would be dominant. Where here, if you have just one of the recessive traits, it'll win out because there's no dominant one to take it over. So let's do some Punnett squares and hopefully this will make more sense. So here's what they look like. Here are your possibilities. You could have X with the dominant gene or X with the recessive gene. And the Y, there's nothing on the Y because there is no gene on this Y chromosome if it's a sex-linked trait. So let's use this example right here. Let's use this one. So let's say mom is XX and dad is XY. So mom is always going to be XX, dad is always going to be XY, but these letters might change. So mom has a dominant gene and a recessive gene. So mom is heterozygous. Dad has just the recessive gene on his X and nothing on the Y. So let's say big R will stand for red eyes and little r will stand for white eyes. So this is an example. Mom would have red eyes. Dad would have white eyes because he has little r. So when you make your Punnett square, it's still going to be very similar to the old Punnett squares that we've done. So X and R, and then X with a big R, because it's here, and then just a straight up Y, and then X with a little r, and then a Y. So your Punnett squares are going to be very similar, but now reading them is a little bit different. So when you look at this Punnett square, 25% of your kids, right here, will have red eyes. This is another 25% that will have red eyes. So out of all the possible kids, 50% would have red eyes. And 50% would have white eyes because this is 2 little r's and this is just 1 little r. So they both be white eyes. And now if I said to you, how many of the females would have red eyes? You'd say you have to look at just the females here. Okay, say one box has red, one has white, so 50% of the females have white eyes. Let's do another one. I'm going to ask some more kind of tricky questions. So let's say this is the new genotype. So mom is heterozygous and dad has the dominant allele. So dad has red eyes and mom has red eyes, and they get together and they have a kid. So then they'd have a daughter here, potential daughter who has homozygous for red eyes. They have another potential daughter who's heterozygous for red eyes. They'd have a potential son who is red eyes, and then a potential another son who is white eyes. So this is why sex-linked traits usually show up more in guys, because if you look at it, white is the recessive gene, and I say, all right, out of all the kids, what percent will have white? And you say, nope, this is red, that's red, that's red, so 25% will be white. But if I said, okay, what percent of all the girls will be white? Well, that would be 0, because no girls got the white. They would be red, they'd be red, but half of the guys got white. So in sex-linked traits, this traits, if it's a recessive trait, will show up more in the male. So let's just do these questions. Let's say this couple had 12 kids. How many of those 12 kids total would have white eyes? So you'd say, okay, 1 out of 4, so 3 out of 12 would have white eyes. How many total would have red? You'd say, all right, well, 3/4, red, would have red eyes. So that would be 9 out of 12 total kids would have red eyes, probably. You said, how many girls with white? Okay, so now it gets trickier. So I said you have 12 kids. How many of them are most likely to be girls with white eyes? Well, 0, 0, so 0 of them would be girls with white eyes. You said, how many of them will be boys with red eyes. You say, all right, well, boys with red eyes is going to be 1 out of 4, so 3 out of 12. But if I reworded that question and said, okay, out of all the boys, let's say I reworded this question now and I said, now you have 12 boys instead of just 12 kids. How many of them are likely to have red eyes? So now since I told you you had 12 boys, you know that half of the boys would have red eyes. So now the question is trickier. It would end up being 6 would have red eyes and 6 would have white eyes. So this is definitely where it gets trickier because you get the boys, the girls, and some genes are hidden because there's only recessive. Let's do this example here. So now I said complete a sex-linked Punnett square where some males get white eyes but no females do. So that's the exact Punnett square that we just made. So you'd make this one right here and you say, okay, some of the males do, half of the males do, and none of the females do. And if I asked you a different question, like so, said now, is there a possibility you can have a Punnett square where all the males get white eyes but no females do? I'm going to tell you right now there is a possibility, and it's hard. You have to think kind of backwards here. But if the female was this genotype and the male was this genotype, if you look at this, both females, 100% of the females would have red eyes. 100% of the males would have white eyes. So if your brain is hurting right now, and this is tricky because it definitely, as I said, is probably the hardest out of all the types of Punnett squares, please rewatch these Punnett squares to make sure that you understand it, especially this one here. As I go over that, rewatch the video, talk to me, ask me questions, do some practice problems, whatever you need to do. And there's another video as well which explains it maybe a different way that'll make it a little bit clearer for you. So this is our sex-linked traits Punnett square video. And like I said, please ask for help if you need any help.